Alright, we got 10.6, number 14. We're supposed to find the area of the region. So, area of the region for polar is integral of 1. So, we need to figure out our boundaries first of all. So, and I've got an a, that's a constant. So, if you just type in y equals 1 plus, or r equals 1 plus cosine theta, it would behave the same, have the same boundaries of integration. So if I graph that, I'm going to zoom in, you get this, and that's why it's called a cardioid, looks like a heart. So if I trace it, I'm starting at theta equal to 0, and of it, and then that will get me half of the area, and then I could just double it. Okay, so I need to know from here to here analytically. That occurs when y is 0. Y is 0 right there, and y is 0 right there. So it's like on the horizontal axis. So if you find y, which is r sine theta, and so y here is a times 1 plus cosine theta times sine theta. Figure out when that's 0, so you can set it equal to 0. The a doesn't matter, so 1 plus cosine theta times sine theta. Set each of those equal to 0. So cosine theta equals negative 1. Well, that is at pi, and sine is equal to 0 at 0, pi, 2 pi, and so on. Alright, so I've got 0, pi, 2 pi. So it looks like I started at 0 and then it goes to pi. So if I trace that, it does go to 3.14 at that point. So from 0 to pi, analytically figured that out. Those are our boundaries of integration. Alright, so now the integral, it's 1/2 from 0 to pi, r squared, which is a times 1 plus cosine theta squared d theta. We have an a squared over 2 I'm going to pull out. So I'm left with 1 plus cosine theta squared d theta. If I expand that, I have 1 plus 2 cosine theta plus cosine squared theta, which means we're going to have to do a power reduction formula with cosine squared. So cosine squared is 1 plus cosine of 2 theta over 2, which is 1/2 plus 1/2 cosine of 2 theta. So 1 plus 2 cosine theta plus 1/2. So I guess we could combine that as 3 halves here. 3 halves plus 2 cosine theta plus 1/2 cosine of 2 theta. Integrating that from 0 to pi, and I still have my a squared over 2 out front. Antiderivative. So 3 halves theta. Antiderivative of cosine is sine, so plus 2 sine theta. Antiderivative to be sine of 2 theta, but then we'd have to divide by 2, so it's 1/4 sine of 2 theta. And I have my a squared over 2 from 0 to pi. Alright, we're almost done here. So it's a squared over 2 times 3 pi over 2. The sine of pi is 0, so the sine of 2 pi is 0, so that's all I get there, minus a squared over 2 times everything. So plugging in 0, I get 0, 0, 0. So looks like I have 3a squared pi over 4 is what I got for the area. I hope that's right.